Here in Station 1, you're reminding yourself about how we write equations. So two things that you might want to know about writing equations. The first is if you're given what's called a verbal scenario, such as this example down here. The first thing you'll want to do is identify the independent and dependent variable. Remember that the independent variable is usually x and the dependent variable is usually y, but we could use any letters we want to represent those variables. The independent is always the input. It is usually the one that you can control. In English terms, we would make it the cause. The dependent is the output. Again, in English terms, we would say the effect, or the result of what happens based on the independent. Some other words that you may want to remember when you're reading these scenarios is if it says more than or increased by, we're talking about adding. If it says less than or less or decreased by, we're talking about subtracting. I put a star next to less than because you'll remember if it says something is 5 less than something, you'll want to say subtract 5 instead of 5 minus, and that's an important distinction. If I'm multiplying, you might see words like per, each, or the product of two numbers. And then least common is if we're talking about dividing. You might see divided by or even quotient of two numbers. Let's take a look at this specific example. Jordan has already been given 6 assignments in algebra. She expects to get 2 more per week. Write an equation A to show how many total assignments she has in W weeks. My two variables that they gave me are A and W. I know that A, the amount of assignments, depends on how many weeks she is in algebra class. So A is our dependent variable. She starts out with 6 assignments and she's getting 2 more. That more means add, and then 2 per week means multiply. So I'm going to say 2W. And now I have an equation where I can figure out how many assignments Jordan has depending on how many weeks she's been in class. The other type of thing you might have to do with equations is to write them in the 3 forms. And we have learned about those 3 forms. We've practiced them several times. They are slope-intercept form, where the m is my slope and the b is my y-intercept. Point-slope form, where I have the point, x1, y1, and the slope m. Remember, in point-slope form, if I plug in a negative where there was already a subtraction, a minus minus or a negative negative makes a positive, so be careful there. And then finally, standard form. I'm not underlining anything here because I cannot go straight to standard form if I'm given the slope, a point, or a y-intercept. It's the only one that I need to start in one of these other forms. So what I'm going to do here is I'm going to give you an equation, and we're going to get it in standard form so that we can practice all 3 formats of a linear equation. But I also think it's important for you to note that if you're asked to write any equation, that means you get to choose. You can do slope-intercept, point-slope, or standard. If you're given slope and a y-intercept, I would suggest you do the first type. If you're given a point and a slope, I would suggest you do the second type. And then if you're asked for a specific one, you can always distribute and rearrange to get it in that format. So the question asks, write an equation in standard form that passes through the point 3, 4 and has a slope of negative 1/3. I would label my point x1, y1. I would label my slope m. And because I have a point and a slope, I would use point-slope form to start out with. Y minus something equals something times x minus something. In my class, we focused a lot about writing the skeleton so that we wouldn't make a mistake later with our signs. Then we can plug in our points. So y minus 4 equals the slope, negative 1/3, times x minus 3. Again, if I was asked for any equation, I could stop there. I was asked to get it in standard form. So now I'm going to need to distribute. I'll get negative 1/3 x. A negative times a negative is a positive. 1/3 times 3 is 1. And if you're not quite sure about that, I would encourage you to use your calculator. My next step is to move my numbers to the right. Oh, look what I did there. I put 5 on accident and I meant 4. Let's change that. Negative 4 and 4 would cancel, and I'll have y equals negative 1/3 x plus 5. Now I've got the equation in slope-intercept form. My slope is negative 1/3. My intercept is 5. Great, but they asked for standard. So I got to have the x and the y on the same side To move the entire x term over, I'm going to add it. And I'll be left with 1/3 x plus y equals 5. You may or may not remember that in standard form a, this first number has to be positive and not a fraction. So to get rid of the fraction, I'm going to multiply by the denominator of 3 all the way across. 3 times 1/3 would be 1x. 3 times y would be 3y. And 3 times 5 would be 15. So my final answer is x plus 3y equals 15. One last thing, if you were given a multiple choice problem like this, and you had the answers, and you weren't sure about this process, remember, anytime I'm given an x and a y, I could plug them in. In this case, 3 plus 3 times 4 equals 15, and I could check. 3 plus 12 does equal 15. So I've got a nice little double check there, and that's right outside my screen. Nice little double check to make sure I did it. And then if I had multiple answers that were like that, I would also want to solve for y to make sure my slope made sense. Just trying to give you a couple ways to do the same thing. Now go ahead and work on numbers 1 to 6.